CNC Machine Crash explained, avoid this. What if I told you one wrong number, one tiny oversight, can turn a precision machine worth lakhs into a pile of broken tools, damaged parts, and lost money? No warning. No second chance. Just a loud crash and silence. But here's the real question. Why do CNC crashes happen even to skilled operators? And more importantly, how can you make sure it never happens to you? A CNC machine crash isn't just a mistake. It's a chain reaction. You programmed carefully. You selected the right tool. You clamped the workpiece. Everything looked perfect. But then, collision symbol tool hits the part. Collision symbol spindle overload. Collision symbol fixture damaged. And in seconds, your entire setup is gone. Here's the truth most people don't talk about. CNC crashes are rarely caused by one big mistake. They are caused by small, hidden errors stacking up. Let's break down the most common reasons behind CNC crashes. 1. Wrong zero setting, work offset error. You set the origin slightly off, maybe by just 1 mm. That's all it takes. The machine thinks it's cutting safely, but in reality, it's plunging straight into the part or fixture. 2. Incorrect tool length offset. Tool length not measured correctly. Then your Z-axis is lying to you. Instead of cutting air, the tool dives deep into solid metal. 3. Program simulation is not equal to reality. Simulation looked perfect, right? But simulation doesn't always account for tool holder size, fixture interference, machine limits. What works on screen can fail on the machine. 4. Feed and speed miscalculation. Too aggressive. The tool can't handle the load, breaks, causes a crash. Too slow. Heat builds up, tool expands, unexpected contact. 5. Human overconfidence. This is the silent killer. I've done this before. It'll be fine. Skipping dry runs, ignoring warnings, that's when accidents happen. White right pointing backhand index. Why do CNC crashes happen even to experienced operators? White right pointing backhand index, and more importantly, how do you make sure it never happens to you? A CNC crash isn't just a mistake. It's a chain reaction. You checked the program. You selected the right tool. You clamped everything perfectly. Everything looks fine until collision symbol tool slams into the part. Collision symbol spindle overloads. Collision symbol fixture gets damaged. And in seconds, everything is gone. Here's the truth most people ignore. White right pointing backhand index. CNC crashes don't come from one big mistake. White right pointing backhand index, they come from small errors stacking up. Let's break down the real reasons behind most CNC crashes. 1. Keycap wrong zero setting, work offset error. Off by just 1 mm? That's enough. The machine thinks it's safe, but the tool is actually heading straight into metal. 2. Keycap incorrect tool length offset. If your tool length is wrong, your Z-axis is lying to you. Instead of cutting air, the tool dives straight into the part. 3. Keycap simulation is not equal to reality. Simulation looked perfect, but it doesn't always show. Warning sign tool holder collisions. Warning sign fixture interference. Warning sign machine travel limits. What works on screen can fail badly in real life. 4. Keycap feed and speed mistakes. Too aggressive. Black right arrow tool breaks, crash. Too slow. Black right arrow heat builds, tool expands, unexpected contact. Either way, danger. 5. Keycap overconfidence, the silent killer. I've done this before. It'll be fine. That mindset. Cross mark skips dry runs. Cross mark ignores warnings. And that's when crashes happen. A CNC machine doesn't forgive mistakes. But it always gives signals if you pay attention. Heavy check mark double check offsets. Heavy check mark verify tool data. Heavy check mark run dry tests. Heavy check mark stay alert every time. Because in CNC, white right pointing backhand index precision isn't optional. White right pointing backhand index, it's survival. A CNC crash is violent. The spindle doesn't gently stop. The tool doesn't slowly bend. It's instant impact. Forces are so high that tools snap like sticks. Fixtures get ripped. Spindles can misalign. And worst of all, damage isn't always visible immediately. You might think everything is fine until your next part fails inspection. Now here's what you came for: the solution. White heavy check mark 1. Always do a dry run. Run the program without cutting. Watch every movement. Check for clearance. White heavy check mark 2. Verify offsets twice. Work offset. Tool offset. Even experienced machinists double check. White heavy check mark 3. Use single block mode. Run line by line. Yes, it's slower. But it can save your machine. White heavy check mark 4. Keep your hand on feed hold. Be ready. The moment something feels off, stop. White heavy check mark 5. Respect the machine. Confidence is good. Overconfidence is expensive. A CNC machine doesn't forgive mistakes. It follows instructions. Exactly. So if something goes wrong, it's not the machine's fault. It's the process. But here's the good news: every crash is preventable. With the right habits, awareness, and discipline, you can turn risk into control. So tell me, have you ever experienced a CNC crash? What caused it? Drop your story below. White down pointing backhand index. Let's learn from each other and make machining safer for everyone. And if you found this helpful, share it with someone who works on CNC. Because one small tip today can prevent a costly crash tomorrow. Backhand index. Let's learn from each other and make machining safer for everyone. And if you found this helpful, share it with someone who works on CNC. Because one small tip today can prevent a costly crash tomorrow.